Okay, welcome. And so we're going to do another example of graphing rational functions. And so in this case here, we're dealing with this one. And so we're going to, again, go through the steps and find out where the asymptotes are located and then the intercepts. And then we're going to use our test points and figure out what's going on when they get, when the x gets close to the asymptotes. So first of all, notice that in this case here we have this bottom, so we want vertical asymptotes if there are any. And so in this case here, this is a perfect square. This is going to be x plus 4 squared. So we have a repeated 0 in the denominator, right? So that means that this is going to have a 0 at, or excuse me, a vertical asymptote at x equals -4. Okay? Yeah, -4. So there's going to be a vertical asymptote at x equals -4. Okay? So let's plot that. So x equals -4 is right here. Okay? And now what about horizontal asymptotes? Now remember, if we look at the degree of the top and the bottom, they're the same. So the rule is we take the ratio of the two leading coefficients. And in this case, we would say y equals 3, right? Well, why does that work? I want to show you another technique that is why that always happens. What we're going to do is, remember, when we're looking for horizontal asymptotes, we're trying to figure out what's happening to the graph as x gets really, really big positive or really, really big negative. So is it approaching a certain value? Okay? Well, one way to see that is to divide the top and the bottom by the largest power of x that's in the denominator. So in this case, it's x squared. So if we rewrite this by dividing the top and the bottom by x squared, we're going to change the way the expression looks, but we're not changing the function. Okay? So what happens? We're going to get 3x squared divided by x squared minus 3x divided by x squared minus 6 divided by x squared. That's the numerator. And then in the denominator, we're going to do the same thing. So we're going to get x squared divided by x squared plus 8x divided by x squared plus 16 divided by x squared. So all I did was just divide the top and the bottom by x squared. And so now I'm going to simplify it and see what it looks like. So this is going to cancel with this. This is going to cancel with one of those. These two are going to cancel. And this x is going to cancel with one of those. So my expression will become 3 over, hold on. This will become 3 minus 3 over x minus 6 over x squared, and then the denominator will become 1 plus 8 over x plus 16 over x squared. Now, remember what I just said. Now what we can do is, let's see what happens to all of the terms as x gets really, really big positive or really, really big negative. Well, all of the terms that have x in the denominator are going to go to 0. Because as x goes positive or negative infinity, all of these go to 0, and look what you end up with. You end up with 3 over 1, which is exactly what we came up with at the beginning. So this is why that technique works. Okay? So to find the horizontal asymptote, you would divide the top and the bottom by the largest power of x that's in the denominator. Okay? And so in this case here, it just turns out to be 3. Okay. So now we've got a horizontal asymptote. At y equals 3. So let's put that on here. So that's going to be like that. Okay, so I'm going to erase this now. Okay, so now x and y-intercepts. Okay, so we know that the y-intercept is when x equals 0. So when x is equal to 0, we get negative 6/16. Okay, so negative 6/16. So it's going to be, when x is 0, it's going to be negative 3/8. So we're down here somewhere. Okay. And then for the y-intercept, that's going to be when the top is equal to 0, right? We're going to set the numerator equal to 0. Okay, right? And in that case, we can factor out a 3, right? So if you find the y-intercept, we can factor out a 3. So we're going to set 3x squared minus 3x minus 6 equal to 0. And so that's going to be the same as x squared minus x minus 2 is equal to 0. And then this factors into what? This factors into x minus 2 and x plus 1. Does that work? X squared, and then we get x, and we get 2x, which gives us minus x, and then we get minus 2. So yes. And so this tells us we have two x-intercepts. We have an x-intercept at 2, and we have an x-intercept at negative 1. Okay, so 2 and negative 1. So right here and right here. Okay, so now the next thing is okay, does the graph cross the horizontal axis? Okay, well, this we're going to factor, and this is going to be 3 times x minus 2 and x plus 1 over x plus 4 squared. Okay, and we want to set this equal to 3. And we want to see if we can solve that, right? So in this case here, how do we want to do this? So in this case here, we're just going to solve and expand it out and solve. I guess that's the way we're going to do this. So let's multiply both sides. And so what we're going to do is, well, let's do it this way then. If we're going to do that, might as well just, I thought factoring would be easier, but let's just set this equal to 3. So we're going to get 3x squared minus 3x. So this is going to be equal to 3. We're going to set this equal to 3. And so we're going to get 3x squared minus 3x minus 6 is equal to 3 times x squared plus 8x plus 16. And so now we can factor out a 3 here, and the 3's will cancel, right? just like we did before. So we can factor out of 3 here. So this is x squared minus x minus 2 is equal to 3 times x squared plus 8x plus 16. So these 3's will cancel. Okay? And then if we move everything over, well, this x is going to cancel with this x, so that's going to cancel. We move this x over here, we're going to get 9x over here, so we're going to get, and then move the 16 over here, so we're going to get negative 18 equals 9x, right? And so if we divide both sides by 9, we get x equals negative 2. So guess what? We just found that it intersects at negative 2. So negative 2 comma 3 is on the graph. So negative 2 comma 3, so negative 2, it's going to, right here. So it does cross. Okay? So notice here what's going on. So it crosses here, it's going up, and it's coming down, and it's going up, and then it's going back. So guess what? This, and again, as this is going towards infinity this way, we know it's approaching this horizontal axis. So now we know it's going to do something like this. Okay. So let's do this. So let's put this back here. Okay. Now again, all we did was look at the points here and see, okay, it's crossing here, and looking at the points, and we know it can't cross over here as x goes to positive infinity, but it does cross here. Okay? Now, all we need to do is figure out, okay, what's going on over here, and that's where we're going to use a test point. So in this case here, I'm going to use negative 5, and this is where I am going to use the factored version. So this is going to be x minus 2 times x plus 1 over x plus 4 squared, so there's 3. Okay, so now if I plug in negative 5 here, what's happening? Well, this is going to be what? This is going to be 3 times negative 5 is going to be negative 7. This is going to be a negative 4. And of course, this is going to be, well, what? This is going to be negative 5, so it's going to be 1. So this is going to be 1 squared, or negative 1 squared, but still it's going to be 1. Okay? So what do I end up with? I end up with a positive value, a large positive value. So I get 28 times 3, which is 84. Is that right? So large value. So I'm definitely going to be up in this quadrant over here. Okay? So in this case, since I'm way up here, I know that this is going to do something like that. Okay? Because I know it's not going to cross over here because it only crosses in one place. So I know it's going to go towards this, again, based on the horizontal asymptote. As x gets large negative, it's going to go towards 3. And as x gets closer and closer to 4, this is going to go to positive infinity. And that's it. Again, make sure you just do these on your own and practice them. The more you graph these, the more you go through the steps and you start getting a handle, it's going to get easier. Okay? Have a great day.